consumer and the patient, but we haven't delved much into how the hospitals themselves are starting to shift, adopting and integrating new digital health technologies. This next presenter is providing state-of-the-art hospitals with solutions that they need to help improve the patient monitoring. So I'd like to welcome Dr. Nersi Nazari. He's the chairman and CEO of Vital Connect to the stage for this next presentation. Thank you.
Thank you, Jill. Thank you, Jill, and thank you for inviting me to this distinguished event. This is a story that I'm going to talk about, is really about our partners. Vital Connect is a company that makes biosensors, but really what we ended up doing, we became a small part of the vision of our key partners. When we started the company, we didn't exactly know what would be best use of our product in hospitals. And two of our leading customers that I will be talking about, they essentially told us, make something that is obviously FDA approved and accurate, but make something as small as possible with data that we can access and be disposable. So that sort of led to us being literally a small part of their vision. Our device itself is very small, and this is the story of how we used their input to make something that is really, really useful, and I essentially tell you those two applications in this talk. We all familiar with the statistics in hospitals, and this is, by the way, the demo of the product as I talk. And as we all know, when you do speaking, your heart rate is higher than usual and so forth. So that's actually very accurate. But as the other screen shows, the statistics in the hospitals we're very familiar with. And I think one of the things that we really trying to do with our technology is to saving many lives and also costs for healthcare providers. Well, we all know what we have today is expensive, messy, and inconvenient. And again, this was the part of the vision of our partners to make something that is small. You don't have to wake up the patients to take measurements or make them inconvenience in the middle of the night and so forth. So that's what we came up with. Also, another point was on the data. The data on the existing systems is also mostly you can visualize it. The nurse can take the measurement and write it down, but it soon goes away. So that was the part that they really wanted that data to be there for future use and do analytics on it as time goes by. So that's, again, the device that I showed you, and it was on the other screen for a few minutes. And again, it's a small device. It goes on the patient's chest, and we put as many measurements as we could. But again, we took the advice of our customers, don't put too many things because they don't want it to be large or to be too expensive that you have to reuse it. Sort of the cycle that this device goes through is essentially the patient is resting comfortably and is not inconvenienced until it's necessary. And the data goes from the device to some sort of a cloud or computer data systems, which is given to the doctors. And as I will talk about later, there are some stuff that immediately when the nurse sees some heart rate is extremely high, breathing rate is going very low, or things of that nature, they can immediately respond. But also, there are things that are more subtle that an algorithm that we develop, or mostly actually our partners develop, can look at that data and make the right judgment for the particular patient. This is, again, the same thing, but in a different sort of a conceptual block diagram. And on here, what I would like to bring to your attention is the upper right, that data aggregation server. So the rest of the system is essentially the wired versions of it available. They're bulky and expensive. But what we really want, that data aggregation that could be useful for analysis of this data. In fact, we ourselves have used that data to improve our algorithms. Because once a clinical trial is done, the data is there forever. If you want to change something and see what happens on your algorithm or your device, you don't have to go through another expensive clinical trials. We've had some pharma companies who want to use this device specifically for that purpose, just because the data is there for future use and analysis. So the benefits are probably obvious by this point. The data is anytime, anywhere. We have a very secure browser-based, which is as secure as banking, maybe even more, to get the data. But not only the nurses can access the data on the nurse station, if something comes up about the patient, the doctor does not necessarily need to rush to the hospital. He or she can also look at the data at his home with the proper credentials and look at that before deciding that if he or she needs to go. And then I will talk about this command center, this aggregation of all this for a group of patients, for a whole hospital, or for a hospital floor that has proven to be very, very useful. And again, the trending and the use of data that we've been talking about. The demonstration was supposed to come at this point. I think you showed it already. So essentially, we have those measurements that was shown a few minutes ago. It is heart rate, ECG, and breathing rates are the three measurements that are mostly used by doctors and nurses. But we also have a measure of patients' movement, fall detection, and so forth, temperature. Again, we took the advice to put as many things as we can, but not too many things that the device becomes too expensive or not disposable anymore. The command center I talked about is essentially the ability to look at accumulation of patients. This can be done by a nurse station that, let's say, is responsible for 14 or 16 patients. This could be done in any logic that is reasonable. For example, a cardiologist could be looking at the cardiovascular patients within the hospital, which may not be next to each other. So we took all the advice from our partners to put all the ability to dice and slice this data in as many ways as possible. And again, in different use cases, they're using it as they think is suitable. All the parameters and so forth that for notifications are used, you can have a setup for a whole floor, individualized. We're also going to be doing machine learning to get this thing better and more powerful as time goes by. The key features, again, as I was talking about, it is light, wireless, and comfortable. The picture there is a comparison with a regular pen, and the device weighs less than half an ounce. Now, one of the things that really makes this thing powerful is the platform solution. We're really not giving a biosensor for day-to-day monitoring of the patients. This platform has enormous power over time. All this predictive analytics and so forth that we've been talking about for many years is really coming to reality with this platform. And once you have access to every heart rhythm over time in conjunctions with motion, breathing rate, and so forth, there have been algorithms that have been developed by us, by researchers at our partners, and so forth, that can do AFib detection, for example, sleep analysis, sepsis prevention. That's a big deal in hospitals. And the proper algorithm can be developed based on breathing rate, heart rate, and temperature. CHF monitoring, two researchers, one in the US and one in Japan, have shown that you can predict a CHF event 1 week in advance. if you have access to this accurate data every second of every day. Again, on the AFib, maybe I'm not using the best example for the standard of the care today, but obviously this is a much, much more comfortable solution. Sleep analysis, again, I've gone through it myself the old-fashioned way, and one thing they ask you, did you sleep well? Again, with the device that we have, you can just do that without any discomfort. In fact, in hospitals, if this is required, you can just do it as a part of the hospital stay without having any additional cost and inconvenience to their patients. Sepsis, again, the statistics is very well known. Every hour of delay in the detection of that can cause significantly 8 to 10% to probability of a death. So it's very, very serious. We have not been to any hospital that has been insensitive to this. Again, this is the power of the platform and having the data every second of every day with those algorithms that us or the expert doctors can develop. The platform has the capability to put essentially any algorithms in Python or MATLAB in. It doesn't have to be Vital Connect, and actually most of them are not. Again, there were cases that you may want to have blood pressure or SpO2. Putting those on a device was sort of counterproductive, making it expensive, big, and so forth. Randy gave a talk, and in fact, I did not get the picture of the latest blood pressure monitor they have, but they have very compact devices, them and other companies, that you can add to this platform. The platform has a data collection capability through the tablet or the devices that we put in, that you can essentially infinitely many other devices can be added. And that is obviously useful when SpO2 or anything else is required. Now, the important thing that came out of this exercise is that if this device is so easy to use and so compact, why should it just not go beyond the hospital walls? And in fact, that's one of the examples that I'm going to show you, because the data can be collected the same fashion. It's easy to use. And then for post-discharge or chronic disease patients, that data can be analyzed, and the response can be done immediately or the next day, depending on the severity of the condition. The two examples, two of our leading customers that really the thought leaders in this area. One is Mercy Hospital System. Mercy is so devoted to this vision that they built a whole center called a Mercy Virtual Care Center. That's a $50 million building devoted just to analyzing this sort of data from devices like ours. $50 million may be a lot of money, but as we all know, building a hospital, each room costs about $1 million or more. So with this center, they can monitor all the 4,000 or 5,000 hospital rooms that they have, plus partner hospitals. The other example is the so-called Admit to Home, and I encourage you to look at the YouTube video that Michael Levine has from Brigham and Women's Hospital. And that's essentially extending the hospital outward, that some of the patients that come to the emergency department, they actually admitted to home, so to speak. And they monitored with devices such as ours. And again, that's the vision that they had, that we had the good fortune to be a small part of it with providing the biosensor. So this is essentially the vision that we have learned to our partners, that the hospital is essentially the center of the care, but not all the care is provided there. There's a whole bunch of more patients can be taken care of that do not come to the hospital, maybe at all or not as often, but they're under care, and if they are doing the medication and so forth, they stay on track, and all of this can be continuously monitored. So on my last slide, I just want to show you the sort of the way that it is patient care is done today. This is a case of coming to an emergency department, and the patient goes to the hospital, care for four and a half days, and then discharged. And then the future and these hospitals that we're talking about, that they are essentially admitted to home, the case of Dr. Levine example, and they are also shown that the patients recover faster and they're a lot happier when they're at home, and they do not also catch anything else that may come from a next patient or things of that nature. And again, being monitored through that. Or the other case is the Mercy case that, again, they go to the hospital, but again, they can be discharged faster and also be more comfortable, recover faster. And the new metric that a lot of hospitals talk about the satisfaction of patient is dramatically goes up when this type of devices are used. Thank you very much. Appreciate your attention.